I am Atharva, a first year BTech student of IT unaided branch of Walchand College of Engineering. Today I am going to introduce a new topic known as partial differentiation. We are going to study about partial differentiation, and first we will study partial differentiation using total differentiation. First we will take a function u that will be in terms of x and y, f of x comma y. Now we will differentiate u with respect to t. Directly differentiate u with respect to t as du by dt, or we will use partial differentiation. Partial differentiation here means like differentiating du by dt but with the help of partial differentiations of x and y, that is dou u by dou x. First we will differentiate u with respect to x, then we will multiply the differential of x with respect to t, so on with other variables present in u, like dou u by dou y into dou y by dou t, and so on. In u we only have x and y, two variables, so we will finish it here. Let's take a example. We have u is equals to x square minus y square. U is in terms of x and y, and x is equals to 2r minus 3s plus 4, and y is equals to minus r plus 8s minus 5, and we have to find du by dr and du by ds. Here dou sign represents partial differentiation, that is we are partially differentiating u with respect to x and also multiplying it with the partial differentiation of x with respect to t. So at finally we can get d partial differentiation of u and with respect to t. Now coming back to the example, we have to find the differentiation of u with respect to r and also with s. Now we know we can use the upper formula in this. We can differentiate du by dr equals to dou u by dou x and dou x by dou r plus dou u by dou y into dou y by dou. We got this formula. We will now differentiate it. Du by dr is equals to, we'll find here dou u by dou x, that will be 2x, and dou u by dou r, dou x by dou r will be differentiating x 2 into 2 plus dou u by dou y will be minus 2y, and dou y by dou r will be minus 1, minus 2y into minus 1. We get du by dr equals to 4x plus 2y. Find out dou u by dou r. Now we will find out dou u by dou s. That will be dou u by dou x into dou x by dou s plus dou u by dou r into dou y by dou s. We will find dou u by dou x, that is 2x, and dou u by dou x by dou s, that will equal to minus 3. So du by ds is equals to 2x into minus 3 plus dou u by dou y is equals to dou u by minus 2y and dou y by dou s equals to 8. So here minus 2y into 8 du by ds is equals to minus 6x minus 16y is minus common 6x plus 16y. Like this, we will use partial differentiation for solving the equations like these. We have learned about partial differentiation using total differentiation or solving questions with help of partial differentiation. In partial differentiation, there are many theorems, and one of the theorem we know is known as Euler theorem. Euler's theorem is basically applied for only homogeneous equations. Homogeneous equations are the equations which are like we have an equation f of x comma y. If we put x is equals to lambda x and y is equals to lambda y, and we get f of lambda x comma lambda y equals to lambda as common to the power n, that will be any rational number, into f of x comma y. Then f of x comma y will be a homogeneous function with degree or order equal to n. As Euler's theorem is only applicable for homogeneous theorems or homogeneous equations, homogeneous theorems, we have various corollaries. Corollaries are also known as subtopics or sub-theorems of a main theorem. Corollary is if we have a equation u that is equals to f of x comma y in terms of x and y, then and it is a homogeneous equation, then x of du by dx plus y into du by dy is equal to n into u. Second corollary, u is equals to f of x comma y, where f of x comma y is a homogeneous equation, then x square dou square u by dou x square plus 2xy dou u dou square u by dou x and dou y plus y square into dou square u by dou y square is equals to n into n minus 1 times of u. Third corollary, it is a different from the first two. Here we will have a function in terms of u, and u will be a function in terms of x comma y. And here f1 comma y will be a different function, and here f1 in terms of xy will be homogeneous function or a equation. Then x dou u by dou x plus y dou u by dou y is equal to n into f of u by f dash of u. Fourth corollary is same as third one but with different condition. Here we have a function f of u, and u is also a function in terms of x and y, which is a homogeneous equation. Then x square dou u by dou x, dou square dou x square, plus 2xy dou square u by dou x dou y, plus y square dou square u by dou y square is equals to g of u into g dash of u. G dash of u means differentially next differential equation of u minus 1. Using all these corollaries, we can solve many questions based on homogeneous equations and finding their partial differentiation. Now we will take an example, and the example will be as u is equals to sin inverse of then find x dou u by this is the example. As we know, first we will find out whether u is homogeneous. No, here we have got u as a function in terms of x and y, as multiplying sine on both sides we will get sin u is equals to x plus 2y plus 3z divided by under root x power 8 plus y power 8 plus z power 8. Here u is a function, and we have a function that is in terms of u, that is f of u, and u is also a function in terms of x and x comma y comma z. So here corollary 3 and 4 are applicable. Now we will see whether which condition we are gonna find, that is x du by dx plus y du by dy plus z du by dz, and this states correctly in the third corollary. The third corollary is here. We got the correct corollary, and now we will solve the question using the third corollary. We will use corollary third. Corollary third states that x of dou u by dou x plus y dou u by dou y plus z dou u by dou z will be equal to n into f of u by f dash of u. F of u is nothing but sin u, and f dash of u is equals to f of u differentiation of f of u with respect to u, that is differentiation of sin u with respect to u is equals to cos u. Now to find n, that is degree of f of x comma y, we will put x is equals to lambda x and y is equals to lambda y and z equals to lambda z. X is equals to lambda x, y equals to lambda y and z equals to lambda z, we get f of lambda x comma lambda y comma lambda z is equals to x plus 2 lambda y plus 3 lambda z divided by under root of lambda x whole power 8 plus lambda y whole power 8 plus lambda z whole power 8. After making z lambda common in the numerator, we will get 2 plus 3z, and in denominator we will get lambda to the power 4 under root x power 8 plus y power 8 plus z power 8, and lambda to the power minus 3 into f of x comma y comma z. So order of f of x comma y comma z is n equals to minus 3. Now according to corollary, x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equals to n into f of u by f dash of u. N is equals to minus 3, f of u is equals to sin u, and f dash of u is equals to cos u. Therefore x dou u by dou x plus y dou u by dou y plus z dou u by dou z will be minus 3 into sin u by cos u, that is minus 3 tan u. So today this much we will learn. Thank you for giving me chance to explain a mathematical topic, that is partial differentiation and Euler's theorem.